Hello. We'll be talking about skewness of data in this session. Sometimes your data is symmetric, sometimes not. That is what we are looking at in this session. Let's start with an example. This is the results of our exam for the class 10 Math G. And this is a frequency table showing the results. So assume this is out of 100% or out of 100. So one person has got 20%, two people have got 30%, 3 people have got 40%, 6 people 50%, 3 people 60%, 2 people 70%, and 1% 80% in the test. Alright, if you want to show this as a histogram, you remember that in a histogram, this axis or vertical axis shows you the frequency, and the horizontal axis shows your scores. Here, the marks are my scores, and these are the frequency. So, we don't have anybody having 10%, so I start here with 0. Only one person has got 20%, so that's 1, that's 2, 4, 6, 8, and 10. Then we've got 2 people having 30%, so that's 30, we go up to 2. And 3 people have got 40%. So that's 40%, we go up to 3, that's 3, and so on. And we've got 6 people who got 50%. So 50% is the mark that has got the highest number of students. And if we keep doing that, it peaks at 50%. And then at 60% it comes down again, at 70% even lower, at 80% you got 1 person only, and at 90% it's back to 0. Okay, once you got these histograms, what we can do, we can choose the middle of each column and connect them together. And connect them together, so these middle points are connected together, and that's called frequency polygon. As you can see, this shape that you're getting by connecting the middles of columns together, middles of the columns at the top together, it's a symmetric shape. Alright? Or these columns are symmetric. Like if you look at this as center, so got this on this side and equally on the left hand side. On the left hand side you got that, and exactly the same on the right hand side. So this is a symmetric shape. If you want to draw it as a smooth curve, it would look like this, like a bell shape. And this type of data, when you have it, we call it a symmetric distribution. This is an example of symmetric distribution, and here we don't have any skew. But not all results are like that, not all data are like that. Let's look at the results of another math class, 10 Math K, for example. And here, 3 people have got 10%, 4 people have got 20%, 3 people have got 30%, and 2 people have got 40, also 2 people got 50%, 1 person has got 20%, one person has got 60%, and another person also has got 70%. Again, if you choose the middle of the tops of each column and connect them by a straight line, you will have a frequency polygon. This time around, this polygon or this shape is not symmetric. As you can see, where it peaks, you're going more to the right than to the left. And in other words, here we have a tail towards that end. Or if I want to draw it as a smooth curve, it will be like that. Peaks here suddenly and then continues to the right. And here, this is called the tail, and the tail is towards the larger values. So we call this positively skewed. So this is positively skewed because this polygon or this curve continues more to the right than to the left. Similarly, we can have the result for another class, say 10 mass K, and the results, if you show them as a histogram, is like that. So one person has got 10%, another person has got 20%, 2 people have got 30%, another 2 people have got 40%, 3 people have got 50%, and 4 people have got 60%. And that's the largest mark here. And no one has got 70%. Again, putting a dot at the middle of the columns at the top and connecting them together, of course you got to start from the horizontal axis and end at the horizontal axis, and you got to go halfway of the length of by the width of this column. So this is half of that. Also, where I'm ending, this is half of the width of the column. That's the width of the column, and I go by half of that to end on the horizontal axis. Starting point and end point. The rest are the middles of the columns at the top. But when you connect them together, this time around you have a polygon like that. If you draw it as a smooth curve, it will be like that. And this time around, you see that more of the results are towards the left of the maximum, and less results are towards the right of that. In other words, we have a tail on the smaller values here. A tail on smaller values. So that means this is negatively skewed. Yeah, you can also judge it without having to sketch that. You can see it from the histogram columns yourself, that this is going more to the left than to the right. And generally, if you have a very large data, it tends to be symmetric. But in the small values, it can be either skewed skewed negatively or skewed positively. Thank you for your attention.